Alright, you're watching this while I'm gone, so today we're doing derivatives of trig functions. We've already talked about, suppose you had f of x was sine of x. We know that the derivative of the sine of x is the cosine of x. And the derivative of cosine is the minus sine. Okay? I personally like to write it like this. I like to go sine, cosine. The derivative of minus sine is just minus cosine. And then think about that. Why is that? Well, the derivative of minus sine is the same as negative the derivative of positive sine. Well, this is cosine, so hang a negative on the front of it. Anyway, the derivative of negative cosine, right back up on top again. And it's going to go like that. Boom, 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 right back to the top. Okay? Now, I think we mentioned those before, so I'm not going to spend a great deal of time on them. How about tangent? So if you have y is tangent of x. Alright, well then the derivative, y prime, how am I going to find that? It feels like this is another way of saying sine over cosine. Wait a minute, well if it's sine over cosine, I can use the quotient rule. So the derivative of the top is sine, derivative of sine is cosine, times cosine, minus the top, times the derivative of the bottom, which is minus sine, all over the bottom squared. Well, that's cosine squared plus sine squared on top. And even the person who slept through Mr. Patterson's class last year remembers that that is 1 over cosine of x squared. Or another way of saying that is 1 over cosine of x squared. 1 over cosine is secant, so secant squared x. That's our thing. So the derivative of tangent of x is secant squared x. Which is kind of cool if you think about it, because if you go look at the Desmos.com, there's tangent. Notice how it always has positive slopes. That's pretty neat. So, oops, suppose I do this. Little parenthesis, secant x squared. What? Dude, check it out. The green one has the same asymptotes, if you will, as who? As the blue guy. And oh, by the way, the green guy is always positive. Yes, meaning the blue slopes, the blue line always has positive slopes. They're very high positives. They come down to a low positive right here at 0. That's the flattest that ever is right as it comes through here, which is what's going on right here. Right there, for instance. And then it gets steeper again. And up she goes. Now, if a person were a betting man, or lady, as the case may be, if a person were to take the old cotangeroonie. Oh, no, you didn't. Well, interestingly enough, it's always negative. So it's going to be negative somebody, obviously. Okay. And, I mean, the last one was secant. I wonder if this one is, I don't know, hypothetical. Oh, shoot. Oh, undo. Darn you. Negative, parenthesis, cosecant x squared. No way. I know, right? Here's how we can show that, though. Remember, that is y is cosine x over sine x. The derivative of the numerator is minus sine times sine on the bottom, minus the top times the derivative of the bottom over the bottom squared. Well, this is negative sine squared minus cosine squared over sine squared. Hey, they have a negative in common. Take it out. All right. Well, that's 1 over sine squared. Or in other words, negative 1 over sine squared. squared, or -1, or negative cosecant squared. And that is what I want you to memorize. Okay. Well, the only two we haven't covered are cosine, or cosecant. What is the derivative of cosecant? I don't know, but I know that it's the same as the derivative of 1 over sine. Now, the derivative of that, what's the derivative of the numerator? Well, it's 0 times the bottom minus the top times the derivative of the bottom over the bottom squared. So that is negative cosine over sine. And I'm going to write it like this for a reason, which I can break into two pieces and write this way times this guy. This right here is cotangent, so negative cotangent, and that right there is cosecant. So the derivative of these guys is negative, and we normally, the big kids usually write negative cosecant, cotangent, but it works either way. In a similar fashion, the derivative of secant is simply secant tangent. Okay? Those are the derivatives of your trig functions that you're going to be dealing with. Okay, this is section 3.6. I'm looking right now as we speak. Yeah, 3.6. Yes, 3.6. Good for me. And there they're all listed out for you. So you're going to be doing some of those. Obviously, you're going to blend some of them in with some other problems, because heaven forbid that you'd just be able to just do those guys. So you might have to do a problem like this. What if I take the derivative of x squared plus 5 times cosine x? Well, the derivative of the first part would be 2x times the cosine plus this first times the derivative of the cosine, which would be negative sine. Not a whole lot I can do with that, other than maybe to write it like this. Not much more I can do. You might see this fella. Hey, let's take the derivative of this guy. So the derivative of the top, well, to do the derivative of the top, I'm going to have to use the product rule. So it's going to be 3 cosine x times cosine x plus the first times the derivative of the second, right? So this is the derivative of the numerator times the denominator minus the top times the derivative of the bottom all over the bottom squared. Well, let's see what I can do with this mess. This is going to be 3 cosine squared x minus 3 sine squared x. Interesting. Okay. Not a whole lot I can do further than that. I mean, I could factor a 3 out of these guys, and then this would become cosine of 2x, and I could factor an 18x out of this guy, and I'd be left with 2 sine x cosine, which would be sine of 2x. But it's not necessary. Just, you know, it is what it is. I would like to point out that this denominator here never equals 0, does it? Which means that this function is where? It is differentiable everywhere. Where? Everywhere. Yeah. Nice. Alright. I don't know. How about this one here? 6x sine x. Oh, dude. You wouldn't. I just did. Oops. No way, Mr. Crew. That's terrible. You're horrible. I know. Look, it's a product 3 times, yo. What do I do now? Well, I'll tell you what you do. In a situation like this, you say, well, all right, take the derivative of the first. So 6 times the rest of it. Plus the first times the derivative of the second times the rest of it. Plus the third. What is the derivative of e to the x? Why, it's e to the x. Bam, dog. Now, what do they have in common? They got a 6 and an e to the x in common. And that leaves me with sine x plus x cosine x plus x sine x. And not a whole lot else I can do with that. Again, this function is continuous everywhere. And it's also differentiable everywhere. So kind of keep that in mind. We're going to keep hammering that over the rest of your life in physics, or calculus rather. So just beware.